Hello everyone. I think that we're getting set up here for the seminar. Megan, could you confirm that you can see my screen?
I can, Andrew.
Okay, so welcome everyone. This is the GeoMapApp webinar on the Western US, and we'll focus on terrestrial data sets in the Western US, including Cascadia. And on the screen here, I've listed some of the topics that we'll cover today. You'll see that there's base map elevations and LiDAR data, geochemistry, geology, some subduction interface depths, seismic tomography, geodetic velocities, earthquakes, gravity and heat flow, and some of the GeoMap app functionality that we'll go over is the manipulation of grids and tabular data sets, the data layering capabilities, import capabilities, and the save session function. So as we go through the webinar, if you have any questions, please type your question into the chat box in the GoToMeeting panel, and at the end of the webinar we'll answer as many of the questions as we can. Also, this session is being recorded, and in a few days' time we'll put it up on YouTube on the GeoMapApp channel. Okay, so let me find my web page. So for GeoMapApp, here's the GeoMapApp webpage at geomapapp.org, and you're probably familiar with this. The download links are over here on the lower left, and above those we have various links, and one I want to highlight is the recently added data. When you click on that, you go to a list of data sets that we recently added to GeoMapApp, and you'll see that for November we added the MIDAS North American geodetic velocity data set from the University of Nevada, Reno group, and Bill Chadwick's Van der Fuca lava flow outlines and fissures data set. And in October, we added the McCrory Attell depth to the top of the subducting slab, and so on down the list like that. Also on this GeoMapApp page, you'll see there's a frequently asked questions link, video tutorials under the help pages. Everything that we see today, all of the functionality is covered in the tutorials here. And here's a list of the tutorials available on YouTube. Each tutorial is a couple of minutes long or so. And if you click the links, you'll be taken to that particular tutorial. On the GeoMapApp channel, you'll see, if we show all the videos, here are all the videos we have. For example, here's the intro one on how to get started, and then there are other ones on different aspects of GeoMapApp. Okay, so assuming that you have GeoMapApp loaded, I'll close that. So I'll go find GeoMapApp and start it. So here we go, we have the three projections available to us. We have the regular Mercator, that's the default. We have Megan, could you mute the participants, please? We have the South Polar view, and we have the North Polar view over here. So we'll start with the regular Mercator projection, since we're looking at the Western US, and we just hit agree. And the GeoMapApp interface opens. So I'm going to make mine fairly big so we can all see. Yeah, okay, so I minimized the GoToMeeting. So here's the GeoMapApp interface, and across the top we have the menus. So over on the left we have the file menu, and under that we have the various import functions, and we'll look at a couple of those import functions. We also have the session manager, and we'll be using that.
Andrew, can I interrupt for 1 second? If you just joined the meeting, if you could please mute yourself, that would be great. Normally I have the ability to do that, but I can't for this person.
Mute myself?
Yes.
Okay. Okay, hold on everyone.
Not you, other people.
Oh, if I can mute, okay. Operator error here, so let me see.
Sorry for interrupting.
Let's see. Megan, how do I do that?
Just proceed. You're fine. It's anybody else who's joined the meeting. Please make sure you're muted.
Okay, thank you. All right. So over here in the file menu, we have the import functions, like I said, then the session manager will see that. And we also have the link to the save options, and we'll look at those later. Under the data layers menu, this is where we find virtually all of the data sets that are built into GeoMapApp. And you'll see that we've categorized them into these upper level categories: geochemistry, geology, geophysics, land topography, and so on. And we'll be using a number of these throughout this webinar. The portals menu contains additional data sets for which we have enhanced functionality. And each one of these will bring up a customized interface, and all of these are have their own YouTube videos to show the enriched functionality that you can gain. The focus size menu is basically a shortcut, and it links to various data sets for the margins, geoprisms, Ridge 2000, and other programs that have been funded by NSF. And all of the data sets you find under focus size come from the data layers menu. So you can often go in either way if you're looking in a focus site area to find the data you're looking for. The overlays menu contains things like the color scale and the distance scale. These are here. You can drag these around on the map if you want, and the distance scale changes with latitude, and the color scale will change if you have a grid loaded and you change the color palette in the grid. I'll just turn those off again for now. And also in overlays, you'll find things like lakes and rivers. We just added a new set of data files for that a couple of weeks ago. And things like under here, you could find the state boundaries if you wanted to overlay those on your images and other things. Under education, there are links to the many margins and geoprisms undergraduate and graduate level education modules, and there's also ones to the high school and intro level education modules that we added. Then under the help menu, there's links to the FAQ. The video tutorials will bring up the page that we looked at just before. Now I have to move my window out of the way. Okay. And I'm going to add a link under here to the recently added data sets, so you can just go under the help and see what was added most recently. If you wish to contact the GeoMapApp team, then there's a comments and suggestions button here, and this will allow you to send email to us directly. The address is info@geomapapp.org, and we're usually pretty quick at responding to your comments and suggestions. Okay, so that was the menus. The toolbar has the pointer, the panning function, just like we see in other map interfaces. A save button here, shortcut. Various zoom operations. This zoom undo is the button we added recently and allows you to undo up to the last 4 zoom functions. So if you have things in the map and you have the map just how you want it to be, and by accident you click on the map and it zooms in or out, you can hit the zoom undo and it will undo that last zoom action. Then this button over here is the shortcut for loading the base map grid. We'll do that in a second. And this button over here is the shortcut for loading the base map grid and for activating the profile tool. Then we have a digitizer and a couple of other things, and then a layer manager icon that we will need in a bit. Then so here's the map, and we're going to look at the composition of the base map. And just before I do that, I note that as I move the mouse around in the map, notice the coordinates of the tip of the cursor are shown in the upper bar here. And when we have a gridded data set loaded, the third dimension value, the Z value, will be added to this display and will appear just over here. So we're going to focus on the Western US in this webinar. And I'll zoom in, so I activate the zoom and select this area. And we're going to go into the Cascade volcanoes. And here you see the tiles coming in. So here we have Mount Rainier, Mount Adams, Mount St. Helens, Mount Hood. Let's go and zoom in on Mount St. Helens. And I'll go in another, just a bit more. Okay, and then I'm going to move that up to the top so I have space down here to move some of the extra windows. So what we're looking at here is a pre-made image of the base map elevation, and it's got a fixed color palette, and in this case it's looking like the brown shades are relevant for this elevation range. So what we can do is load the underlying grid and allow us to do much more manipulation of the base map data. So if we trigger the grid load function, so at this point we're pulling the underlying tiles from the server, and the server is located at the moment on the west coast of the United States. We are in the process of evaluating putting the tiles on the Amazon cloud, and that may help speed things up. So you see that the map has changed color, and when the processing window is finished, we'll be able to activate the functions. And you'll also notice another window appeared back here, which is the grid manipulation window. So in here, this color graph is a histogram showing the elevation histogram for this map area. So we see that we have a peak of elevations between about 900 and say 1400, and it tails off to either side. So we can change the artificial illumination by dragging the sun over here. This is what this area is for. So let's change this sun over to the east, and we can drag it down, say, to the south, and let's put it back to the northwest. So that can be handy for picking out trends in features. And we can draw contours, and there's a contour shortcut here. And GeoMapApp has a guess at the range of elevations, the range of the grid in this case, and suggests a contour interval, and you can change all of those, or we can just accept those, and the contours appear on the map like so. And let's just say we're looking for a base map, and that's the base map we want. Then we can save that image just by hitting the save function up in the toolbar up here, or going into the file save menu, and we see we have various options for saving, including the image options down here and the grid options up here. Okay, so let me find the grid manipulation window again. So the next button along allows us to take a profile to generate an elevation profile, or if we have any other grid type loaded, it will generate a profile, a cross-section of that particular grid. So we click that, and let's draw a profile across there, and here's our profile window. As we move the mouse around in the profile window, you'll see there's a small red dot on the profile line on the map that shows where we are. And because we have the grid loaded, you'll notice just here is the elevation value at the position of the cursor, and up at the top of the GeoMapApp window, there's the elevation value given up there too. So as you move around, that changes. So that might be a useful way to quickly find the Z value wherever the mouse is. Okay, so that's how you can take a profile, and there are various save options available for this profile. You can even save the ASCII data as a table, or a couple of image options. So I'll just get rid of that and go find my window again. We can also change the vertical exaggeration, and we can switch from 2D to a 3D perspective view. So if we click over here on the 3D option, then I get a window that looks like this. I'll make it a bit bigger. And the control buttons over here allow us to rotate and tilt this image. So if I rotate the image, then we can see Mount St. Helens in all its glory there. And we can change the tilt angle, look at it from more vertical or more horizontal. And when we're happy with the low resolution rendition, then we can click render as an image, and the higher resolution version comes up. And we have the lower resolution just to make it go faster. Okay, so we'll switch back to the regular 2D. So that's the built-in base map, what we call the GMRT, the Global Multi-Resolution Topographic Synthesis. And you'll see down at the bottom the elevation data sources. Sometimes there's a list of country flags here, it lists the countries from which we have elevation data. So let's go and load some additional high-resolution data. This is the default 10-meter USGS gridded elevation data set. I forgot to say that earlier, sorry. But we actually have some LiDAR data, the 3-meter LiDAR data, and we can look at that now. Now, to speed things up, I'm going to close this base map elevation grid. So we're now just looking at the pre-made JPEG image, and I'm going to go find the LiDAR data. So for LiDAR, we can find the data sets various ways. First, this is the Cascadia site is a GeoPrisms focus site, so we could go under focus sites, GeoPrisms, Cascadia, and under land topography, we see LiDAR data for various volcanoes and features in the Cascades. Or if we didn't know it was a focus site, we could just go into the Layer Manager window menu, and if we click the top item here, then it just makes it a bit easier to navigate the menus. If we don't click that, then we go through the cascading menus and we go into topography, land elevations, by region, and sometimes these menus can get quite wide, but if we just click on the top one, then we can type LiDAR up here, hit return, and all of the LiDAR data sets will appear. And down here we see Cascade's 3-meter LiDAR, and we just hit Mount St. Helens and load it, and it will start pulling in the high-resolution tiles for Mount St. Helens. So it's pulling them in from the server, and there we go. So in the Layer Manager window that appeared when the grid loaded, we have an opacity slider bar, the transparency, and we can use this to compare the underlying layer. So in this case, the underlying layer is the default 10-meter USGS National Elevation Dataset. And when we slide the slider that way, we see the much higher resolution 3-meter dataset. And all of the functions that we've looked at related to grid manipulation, the contouring, profiling, the sun illumination, the 2D, 3D, all of that is available for this gridded dataset as well. Whenever this window appears, those functions are enabled. So just to show you the quality of this LiDAR data, I'm just going to pan slightly north of here, of the crater. We'll just let the tiles come in. I think it's just in here, yeah. And if I zoom in one more step, so zoom and it'll still keep pulling the tiles in, then here, with the transparency, as we slide the transparency backwards and forwards, we can see just how much detail is afforded to us by the LiDAR data. So we see the road, the car park here for the visitor center, and even some hiking trails around here. So it's quite tremendous how detailed this dataset is. We are in the process of evaluating adding extra LiDAR datasets, and hopefully we'll have more in the base map coming soon. Okay, so we've been looking at gridded datasets so far, solely the elevation. Well, we'll stay looking at a couple of more other gridded datasets, and we'll have the similar functions available to us. And we'll look at the McCrory Attell Cascadia slab depth model, and also at a seismic tomography model, the ambient wave 3D model of Gao and Shen. So for now, I'm going to find the grid manipulation window so I can turn the grid off. So if I go to Window and hit Contributed Grids, then that window appears. It was just hiding behind the main window. And to speed things up, I'm going to hit the Close button here. Okay, and I will zoom out. So zoom out a few steps. Let's see where we are. Okay, so that should be good. And then I'm going to go find the McCrory Attell dataset. So again, because this is a GeoPrisms focus site, we added the dataset to both the focus site menu and the main data layers menu. And we'll just go in and we'll click on the tear off menus and we'll type in, let's see, MC, and we'll see what pops up. Okay, so I just did a a basic text search there, and we see that the Juan de Fuca plate subducting slab depth model from McCrory Attell came up. We also have the Syracuse and Abras and USGS slab 1 models in there, but neither of those have a Cascadia area model. So with the Juan de Fuca plate highlighted, we hit load, and the model comes in pretty quickly. I'll minimize that. And here it is. So let me just go back to the pointer. Now we have a gridded data set loaded, and you'll see just up here in this area here in the toolbar, as I move the mouse around, the depth beneath the cursor is displayed. So over here, the slab is very shallow, and as you go down the subduction zone, it gets deeper, of course. And just like before, we can do those functions of adding contours, say. So GeoMapApp is guessing 10-kilometer contours. That sounds good. There they are. We can, because we're going to load another grid in a second, let's change the color palette as well. So I find that window again, and in the grid manipulation window, we'll see the palettes menu, and I'm going to switch it to the black and white menu. And then we'll normalize the distribution. There we go. And we'll turn off the sun illumination to make it stand out a bit more. So this is the depth to the top of the subducting slab under Cascadia of the Juan de Fuca plate. And if we use the slider bar, we can make it transparent and see where we are geographically. And now we can load in another data set and do some proper layering, so we can do some compare and contrast type studies. So let's go find the seismic tomography model of Gao and Shen that I think they released in 2014. So we'll go to data layers, and we can go into geophysics and under tomography models, and remember we can always click on the tear off menu to make it easier to navigate. North America Cascadia, Gao and Shen, and let's choose, say, the 94-kilometer depth slice. So this is the shear wave velocity at 94 kilometers depth. So we'll click on that, and it will come in. So there it is. And just to show you the other data set, the McCrory Attell slab depth is still there. It's just underneath the Gao and Shen tomography layer. So let's change the color palette so it resembles the figures that appear in the Gao and Shen paper. And I should say that in order to see the sources of these data sets, in the layer manager, these little tourist information symbols take you to those places. So here's the McCrory Attell paper, and if I click on this one, then it will bring up the Gao and Shen model here. And if we look at their figure 6, so this shows that they're using the, I think it's the Jet 2 invert color palette, and we can replicate that in GeoMapApp. So here we go. I will go to the color palettes menu, more palettes, and here we have about 60 odd color palettes that are now available. We added these a couple of months ago, and these are all of the ones that are available in GMT. So if we find the Jet 2 invert and hit close, so it's colored it, we just need to do the normalization distribution again. So we click the normalization button here, and we'll change the range so it's closer to what they have in their paper, which was 3.8 kilometers a second to 4.8, and we do that by sliding the gray lines around to change the color range. And we'll turn off the illumination, and let's just move that out of the way. And now when we find their paper and bring up this, let me see if I can move their model up to the edge. Yeah, move this way a bit. So you see that their model ends at the coastline here in this figure. And for us, if we find where the coastline is by changing the transparency, so we see there's the coastline. So the edge of their figure is roughly here. We could always, of course, draw the US state boundaries on here to make it easier. And we see we have a very good match. It's the same data set, of course, of what's shown in their paper. And again, as we move the mouse around, so just above the mouse here in the top bar, we see the Z value is listed. In this case, it's 3.9 kilometers a second for the shear wave velocity. And because we have these two data sets loaded, let's go find, I'm going to bring the McCrory Attell slab model up to the top, and we can make that one, well, it's already somewhat transparent. There we go. So the Gowan-Shen model is the 94-kilometer depth slice. And here we have the McCrory Attell subducting slab depth model that has 10-kilometer contours on it. And so the intersection of these two planes is 94 kilometers. And if we were to count 10, 20, 30, 40, 50, 60, 70, 80, 90. So these two planes intersect somewhere where my mouse is running up and down the model here. So in those a few clicks of the mouse there, you could see that we quickly brought in these data sets, allowing us to integrate the different data sets in one simple interface. Well, let's add a tabular data set to the mix here. So far we've been looking at gridded data sets. We have the slab depth model, we have a tomographic model, and you'll have noticed in the menus there were other tomographic models that are in there. We're trying to put all of the models that are at the IRIS Earth model website into GeoMap App, and we've got quite a few in already. And so now I'm going to add a data set that was just released last week, and this is the MIDAS geodetic velocity data set that was made by the University of Nevada Reno group, the geodetic laboratory there. So for that, if we go up to data layers, then again we can, if we don't know where it might sit, it just happens to lie under geophysics, lithospheric plates, and if we look under here we have plate deformation and velocity, and there we see them listed, the MIDAS models. If we didn't know that, we could just type MIDAS in the top here, hit return, and it would highlight these data sets too. So they offer a couple of different data sets, and in this case these are the ones that are in the North American reference frame, and I'm going to choose the median spatial filtered data set. So we click OK there, and the tabular data will load. So let me minimize that and get rid of that, oops, this web page. Okay, so a couple of things have happened here. We have the shape of the windows changed. We have a control panel over here that allows us to control the symbols, the circular symbols that are on the map, the tabular data. And down below the map, we have the table of data itself. And what we can do is there's various functions available to us. So first off, in the table below, this is the MIDAS data set. Here are the links to the station. So if we click on one of these, it should bring up the link to the station page here, like that. Okay. And let's get rid of that. Okay. Then we have the latitude, longitude, height, and we have the different values over here. And in this column at the edge, we have the up velocity. So we can drag these columns around. So let's bring the up velocity, the vertical velocity, closer to the center, so it's easier to see. And if we click on the column header, then we can sort this data set here. So if we click the up velocity column header, we sort it in reverse and regular order. And for tabular data, we can click on any of the records in the table, and that particular station will show up on the map. So here you see it turn red, and if I click on another one, this one turn red. And conversely, we can click on the map and it will light up the record in the table below. Okay, so we have the tabular data loaded, and we can do a couple of things with the tabular data sets. One is we can color and scale the symbols. So let's color these up velocities, this MIDAS data set. So here we have, I hit the color button over here, it brought up this window. And these are all the numerical columns that I can use for coloring. And we go find the up velocity, millimeters per year, and hit OK. And here, I'm going to change, because the UNR group tends to use the Polar 2 palettes. I'm going to change the color palette. Oops, wrong button, sorry. I go to palettes, more palettes, and go find the Polar 2 dataset there, palette, and hit OK. And they typically have the range going from -3 to +3. So we'll do it like that. And so now we can compare to what they have in their papers. And we can also scale these symbols. So we'll hit Scale. And let's scale them also on the up velocity, for want of a better thing. There we go. And so now we drag these lines around, and the bigger the symbol, the higher the up velocity. So in that manner, you see that we have a number of data sets layered, and we can start to do these integrative studies. Everything is plotted in the correct geospatial reference frame. And let's say we want to save what we have on the screen. There are a couple of ways we can do that. Actually, before I do that, let me just show you the graphing tool. And that will allow us to graph any two of the tabular values, numerical values, together. So for the x-axis, let's choose, say, we'll have the time series duration on the x-axis, and for the y-axis, let's look at the uncertainty in the up velocity. So up velocity uncertainty. And so we have a simple graph pops up, and we see some trend there. The shorter the duration of the station, that increase in the uncertainty there. And we can change the scale on this by dragging these blue lines left and right to change the scaling of the axes, like so. And we have some save options under the save button there. So I'm just going to kill that for now. So let's say we want to save this image, or actually save this project. Well, we can do it two ways. First, if we just want to save the image, we go to the Save button, and there's a shortcut to it here. And if we hit Save Image, let's say, and we'll get rid of the inset, and we'll stick it on the desktop, and we'll do that. And there's the image that was just saved. But let's say we want to save the project, so we may want to share what we have with a class or with our colleagues, or just save it for use later. If we go to File, Save Session, then the Session Manager allows us to save this current session. And we hit that, and just we can choose the file name or just accept the default. And a very small XML file appears, and we don't need to worry about what's inside it. But what it allows us to do is, I'm going to start a fresh application of GeoMap App with nothing loaded in it except the default base map. And then I'll go and import that save session. So I go down to the File, Session Manager, Import Save Session. And this is the file we just made. And we hit Save and Import. And there we go. So it loaded all of the data sets, and it preserved the scaling and the colors of the symbols. Now, just in the background is the semi-transparent McCrory Attell grid. And we do have the grid, the tomographic grid in there as well. We just have to activate it. So for that, I'll find the grid window. And if I switch to the tomographic grid and just hit reload, then it should bring it in just as before with the same color palette, the same sun illumination turned off, and we can bring the McCrory Attell up to the top and bring the MIDAS data up using the layer manager over here, and we're back to where we started. And when we resize, we'll be right back to how we finished and saved the session. So maybe for people who teach classes or labs, the save session function can be viewed as a very quick way of storing a session of GeoMap App. And when your students import that session, they all start at the same place. So it can save a lot of time for getting people all beginning their explorations of GeoMap App at the same starting point. Okay, so we've gone through quite a bit of functionality there, and I'm going to switch gears now. I'm just going to kill this GeoMap App and go back to the one we had at the start. So let me get rid of the gridded data sets and we'll switch and look at some of the more geological aspects, including the geochemistry and the geological maps. So there are a couple of ways we can kill some of these data sets so we don't get too confused. So we can just hit the X's in the layer manager, and now we're back to the default map. Or we could have, in the grid manipulation window, hit the close button like we did earlier. Okay, so now I'm going to load, for this same Western US area, we'll load the Smithsonian Global Volcanism Project. And for that, we can go into data layers, and we've put it in a couple of places in the menus. And again, if we don't remember where it is, we can just do the tear off menus and type in Smithsonian up here. So let's do that, if I can type correctly. Okay, and we'll see what was highlighted. And right there we have the volcanoes and seamounts Smithsonian GVP. So we'll click that one and hit go, and it will load those points. So these are the Smithsonian GVP volcano locations, and we can change the symbols there. So if we go to configure, then let's say we want to make them, we'll color them red, and so we'll click on, oh, I'll just show how I did that. I clicked on the color all, and I'll drag that up and drag this bar up to the top and hit OK. And then we'll draw triangles because volcanoes are typically triangular shaped, and we'll do big size symbols, so let's do big ones, and we hit OK. So there we have the Smithsonian listed volcanoes. Here's Rainier, Mount St. Helens. And just like before, if we click on these symbols, then the relevant symbol record will light up in the table below. Or we can go to the table and it will light up in the map. So let's now load on top of this the EarthChem geochemistry data. So for that, we can go into the navigation window for data, and let's just go up to, we'll close the geology, oh, we have to go over a little bit, close the geology, close the geophysics, and here's the geochemistry. So here we have EarthChem data, and here we have the Cascadia dataset extracted from the EarthChem portal a couple of months ago, and we'll hit OK. And the EarthChem portal gets updated frequently, and when it gets updated, we update the menus in here in GeoMap App. So we're loading this tabular data set, and it tells us that 55,000 records. We'll plot all of the data values, and there they are. So if we do the coloring and scaling and graphing operations, we can have some powerful analytical techniques at our fingertips for looking at this geochemical data set. So let's say color the symbols on, say, alumina Al2O3. And so like before, we can drag these lines around to change the range of the palette. Okay, excuse me. And we'll just budge that down there. Let's say we want to scale them on a different quantity. So this time let's scale on, let's say, MgO. Okay. And we can drag this line closer to the histogram peak. So we change that. And because there's a lot of data points here, let's shrink systematically all these symbols, and we can do that in configure if we just drag this, and it's like a scale factor applied to everything evenly. Okay, so the symbols go smaller. Okay, so there we have the Smithsonian volcanoes are still shown as the red triangles. Overlaying on that are the EarthChem data values. And here's the EarthChem table down below. And you'll see if we scroll over to the right, we have the analytical values right here. And if we were to click on the information link here for the source of data, this brings up the EarthChem homepage, and we're actually going to switch that to the portal, and the portal is where we got the data files from in this case. Okay, so this is the scaling and the coloring and the changing of the symbol size routinely. We can do the same sort of graphing. In this case, let's graph, say, silica on the x-axis, and on the y-axis, let's do, say, potassium oxide. There it is. And we'll hit OK, and we get a window that looks like this. And again, we can drag the axes to change the range of data. And we have the lasso function that can be very useful for highlighting certain records. So there are a couple of ways to activate the lasso function. Over in the right pane, there's a lasso tool here, and the same thing is over in the graph function here. So just because I'm here, I'll hit this one. So let's say we want to highlight all the records in this central region. So using a freehand draw, I'll just draw a line around there. And all of the selected symbols are illuminated with a white outline on the map, and they're also illuminated in the record table below. So as we scroll through here, we see all the ones that are blue shaded are in the selected range. And for these selected ones, we have a few options for saving them. Let me just make this a bit wider. And under the Save, I'll just make it even wider still. Under the Save menu here, drop-down menu, we can save the entire table in different formats, ASCII, tab-separated ASCII, or Excel, or KMZ. We can save the data points that are plotted on the map as various formats as well. And the ones that we just selected with the lasso tool, we can save those in those ASCII or Excel or KMZ formats too. And so that could be a good way to save a subset of the data and pass it to your colleagues or store it for later. Okay, so here we are in the Cascade region, and we've looked at some geochemistry. Previously we looked at the geophysics, and I'm just going to get rid of this graph window and move the layer manager out of the way. I will say if the layer manager disappears for any reason, like we kill it, we can just bring it right back by clicking the symbol up here. Okay, so let's now, as we're getting close to wrapping up here, let's load a couple of geology maps and lithology maps. So I'm going to go to the data, let's say we didn't have that either. I'll go back to data layers, and under geology we see geology maps. And because there's quite a big menu in there, I'm going to do the tear off menus again. And we go geology maps, North America, United States, and we go down and find Washington State, and we'll look at what we've got there. So we have various options. There's the lithology that we get from the USGS. We pull it in as a web mapping service, so whenever USGS changes their map, we automatically get the most up-to-date version of it. So let's bring that in. So there it is. Let's actually zoom in quite a way. So we'll go into this area here. Okay, maybe we'll go in even further. And then we can put the faults on there too. I saw that faults were listed in here as well. So let's put the map faults. There they are. And we'll get rid of that. So in the layer manager, we can see that we have the faults. These are these thin black lines in various places. I think maybe if I go down here, there might be, yeah, there's some more. And we can use the transparency tool to highlight the faults. We can also use the transparency tool to make the lithology map disappear. And we can bring the EarthChem data back up to the top. So here we have the, let me make the lithology map semi-transparent. There we go. So we have the red triangles reflecting the Smithsonian volcanoes for this area. We have the circular symbols reflecting the EarthChem geochemistry. And then we also have in the background the latest lithology map for Washington State and the faults there. And just like we did before, we can do the whole save session operation, and it will save the session, and next time we import that session, it will load these layers just as we see them here. Okay, so the last couple of things that I want to show are one of the portals, the centroid moment tensor portal, and earthquakes, and then a couple of import functions. So let me just get rid of these layers that we have in here. So I'll get rid of the tabular data and the geology maps, and I'll zoom out a bit more. Okay, and then you can see tiling bringing the base map in. I'll go to portals and find the earthquake focal mechanisms, CMT, and it will load the points. Now, at zoomed level where we're zoomed out quite a way, we just see the location of these final solutions. But if we zoom in a little bit, then there we go. Once we zoom beyond a certain level, we see the beach balls. And if we select any of these beach balls, then down at the bottom of the GeoMap app window, you'll see the final solution is listed. And so we can just choose that and see how it changes. Over in the right, you'll see the vintage of the data set, and we last updated this, I think, in September, and there's always a delay for the final solutions becoming available. So we're going to update it again probably in the next couple of weeks before AGU, and so this may get up to maybe June or July 2016 with the update. Again, if we click the information symbol, we get taken to the source web page for the data. And so that's the CMT portal. Now, if we want to look at the earthquakes in this region, we know there's not that many earthquakes in the Cascadia region compared, say, to the Aleutians, but we can go and under data layers, we'll find geophysics, earthquakes, earthquake locations, and let's say plot, because there aren't that many, let's plot one of the catalogues that has quite a few. So this will plot everything with magnitude greater than magnitude 5 for the 56-year period, 1960 to 2016. So it's pulling the earthquake locations in from the server, and you see there's 74,000 of them, plot all records, there they are. So these symbols, the circles here, are the earthquakes, and in the table at the bottom, we link to the actual USGS page for that earthquake for every single one. So that might be a good way to get extra information. There's the location is listed there, the magnitudes and depths and so on. And all of the tabular functions, the coloring, the scaling, the graphing, is all available. The lasso tool, because it's a tabular data set, is all available here as well. So the last two things I'll show are import functions. So for that, let me, actually I just have to do one thing here. Let me go find my import tool. So I'm going to go and import a tabular data set. Now because we have a couple already loaded, let me change the symbols of the table that we're going to import. It will be a heat flow data set for this region. So I'll go to File, Import Tabular Spreadsheet, and in this case I happen to know it's going to be a tab delimited ASCII file, just a regular data table, and I need to go and find it. So let me go up and I go find, I put it in Dropbox I believe, in here, okay, heat flow. So here's the data set, it's the Pollock data set from 20 odd years ago. And we hit open, and let me find this, and I hit OK. And so GeoMap App recognizes latitude and longitude column headers, and for this we're going to draw squares instead of circles, and I'll make them bigger. And I'm going to make the data set editable, so we can edit imported tables. So I'll tick the editable box there and hit OK. Alright, so here are the heat flow data values from the Pollock Attell data set, and let's say color these on the heat flow value that's there, and I'll drag that towards the peak to make them show up a bit better. And because I made the data set editable, then I can drag any of these symbols around and it will change its location on the map. So let's say it needs to go up there. And if you actually look in the table below the map, as I move the symbol around, the latitude and longitude value change in real time. So this is actually could be useful if you're trying to locate stations for an upcoming field program. If you want to know where to put your instruments, you can drag them around like that and then save the table as an ASCII or spreadsheet file. And it's also a precursor to the survey planning tool that we have. That's a portal that allows us to do a lot more. It's just in beta stages at present, the survey planner, but it will improve in coming releases. Okay, and then the other thing I wanted to show was the grid import. So let's say you have a grid import, and I just need to go find my, oops, wrong place. I just need to do one thing to get rid of some files that we're going to actually produce in a second. Okay, so let's say you have a netcdf file, a gridded file. You could have got it, maybe created it in GMT, for example. And actually, in this case, I made this one using the GMT Near Neighbor program. And this is the PACES gravity free air anomaly dataset for North America. So here is the grid file, and I can import it to GeoMapApp. So I'm going to go to File, Import the 2D grid file from a local file system. And I have various options here for the format. The netcdf is the correct one. And I go find it, and it is in this space, and I hit open. So GeoMapApp instantly reads the grid file header and gets the information out. That looks okay. And so now GeoMapApp is in the process of churning through the contents of the grid file, and it will start building the tiles just as if it was a built-in data set. So it's going to build a parallel tile structure, and here we have the data set. So let me turn off the illumination so it stands out a bit more. So this grid that just came in is the PACES gravity that we imported as a grid. And you'll see as I move the mouse around, because it is just an import and I did not choose the units, it's got a default of meters just at the top of the screen there. But on the import function, I should have pointed out that you can actually specify the units of the grid, and they will be displayed at the top of the map there. So here is the PACES gravity, and if I find the Layer Manager tool, then again I can bring different data sets to the top. So there's the heat flow, and we have the earthquake fulcrum mechanisms coming through, and the earthquakes as well. So you'll see that very easily we layered various data sets, geoscience data sets that are useful for the community, and they're all presented in this integrated manner. So I've run through all the things I wanted to show. I'll just reiterate that if you want to save a project, you can go to the File, Session Manager, Save Current Session, and it'll save everything you have on the screen as it is. But if you have questions, if you want to type them into the chat box, and I'll do my best to answer your questions. Okay, so let me see if any questions came up. Maybe, Megan, if you notice questions coming in on the functionality of GeoMapApp, if you could read them out and I'll answer them.
There were actually a couple of questions already, and they related to using version 3.6.3 on a Mac. So somebody asked, why do the menus look different from yours on a Mac?
Oh, okay. So I'm using GeoMapApp on a Windows PC here, and the Java, which it runs GeoMapApp, Java on a Mac is slightly different to Java on a PC. But the content is all there, the menus are all there, they may just be in slightly different orientations. And the shape of some of the windows changes slightly, like the buttons around here change a bit as well. But rest assured that everything you saw in GeoMapApp is available on the Mac version as well.
Okay, and then somebody else reported that in Mac version 3.6.3, they were also having trouble locating the McCrory or tomography data.
Yeah, so for the data sets, I will say that in GeoMapApp we have roughly 4,500 different data sets in the menus, so it can indeed be overwhelming trying to remember where they are. So that's why when you go on the data layers, that's where all the data sets, or virtually all the data sets, sit. If you click on the tear off menus, then it affords us two things. One is we get more easily navigable menu structure. We just turn down these little toggles here, and we can navigate that way. Or we can type a keyword up at the top here. So if I just type McCrory, and you have to spell it correctly, otherwise it won't show up. It just uses, basically, it's using the Unix grep command to find the text string. And so there it is there. So you don't even have to remember where it is in the menus as long as you remember what it's called. So type it in at the top, hit return, and it should highlight it there. Okay, any other questions, Megan?
Yeah, they're coming in like crazy. So ask, is it possible to export data directly to ArcGIS, such as layer or shapefile?
At present, we do not have an export as a shapefile. If we go to we can go to the save menu, so you can see, and remember we can get to save either through the shortcut here in the toolbar, or in the menu save, it's the same thing. So you'll see the geotiffs, KMZs, and JPEG and PNG are the image formats. So we don't yet have the capability to export shapefiles. If you have grid data loaded, in this case we have the PACES gravity grid, then you'll see various options are available to us up here.
So the next question, I can actually answer this one. Somebody asked, are the NavDat data, igneous rock geochemistry, included in the EarthChem data set? And I can report that yes, data exported from the EarthChem portal do include the NavDat data.
Right. And for the EarthChem data set, when it's loaded, actually, let me just minimize that again and close that. And do I still have the... So if I just close the tabular data I've got loaded and reload the EarthChem geochemistry, then I believe it says the source, whether it's NavDat or PetDB or EarthChem or the other places. So let's have it come in here. Okay, we'll plot all the records. Yeah, so right there under source you see NavDat. And if you were to scroll through there, you see the different sources as well.
Yes, there are many different sources. Next, we have a question asking, will the data search look in the window area only?
Will the data search look in the window? Oh, no. So I understand the question now. So the data search will search the entire GeoMapApp menu structure, regardless of where the map is displayed. So everything in the menus is fair game in the search.
And that looks like it. If anybody else has any burning questions, this is your last chance in this venue. Of course, you're always welcome to send us questions. Okay, here's another one. Can I show only one type of data from a file? For example, only uranium-lead dates from NavDat.
For that, what you would need to do, I think, is select all the records in the table with NavDat, and you can do that if you click on a record in the table, and you can use the shift key to select multiple records like this. Then if you select all the ones with NavDat and all the ones that have your analytical values, then you could save those. Under the save, you could save your selection as a file, and that would just have those. But I think if you go to the original source, which is the EarthChem portal in this case, I think, Megan, am I correct that you can choose those different things at that level?
Yes, I believe so. And I want to report that the EarthChem portal includes data from PetDB, SedDB, GeoRock, NavDat, the USGS, and Ganseki. And yes, you can filter based on those things.
Okay, so you can filter either at the EarthChem portal level or here using the tabular level.
So we have another question. Can you please explain a bit of the digitize function?
Okay. Well, I will point out there is a video on that, so let me just bring up the video for it. Let's see. Working with data, digitize, so right there, analyze data, you see. Oh, there we go. Right, so this video goes through and explains how to do the, oh, let me move that, how to do the digitizing. And I think that the easiest way will be for you to look at that video, and it should answer all the questions. I will say that we know that the video is, that the interface for digitizing is not perfect, it's fairly rudimentary, and on our to-do list is an action item to improve it a bit, but it does work quite well.
So I think that might be it. I think it would be great if we could remind everyone about our events at AGU. Andrew, did you want to mention anything?
Yeah, so if you want even more information about GeoMapApp, we're having a user lunch on Wednesday, the 14th of December at AGU. It will be at a location just a couple of blocks from the Moscone Center. And I looked this morning, and there are so far 31 people signed up, and we have a limit of 40. So if you have not yet signed up and want to come to it, sign up soon to guarantee your space. And like I said before, if you have any other questions on GeoMapApp, just feel free to send us email. Remember, you can go to help, comments and suggestions, and we get that in our queue, and we'll answer it as best we can. And also at AGU, there'll be an AIDA booth. AIDA is the name of our group in which we generate the geochemistry data under EarthChem, GeoMapApp, and a list of other tools and resources for the community. And we will have an exhibit booth, which is booth number 244. It's in the exhibit hall. Just look for AIDA. And I believe there are a couple of other events as well, an iSamples workshop, and if you look on the AIDA webpage, we do list the AGU activities. So if you want to come to the AGU booth and ask us questions, we'll be more than happy to try our best to answer them. Or if you want to sign up for the GeoMapApp lunch, we'd welcome your participation. Okay, so at this point, I think we've had all the questions answered. Thank you very much for attending the webinar. This webinar is being recorded, and we will put it online. I'll put it on the YouTube channel, and I'll send a link to all the people who registered for the webinar. So if you want to look at it in your own time, you may do so. Okay, so thank you. And oh, someone just said, will you be at the SEG convention next year? I don't believe we will. We tend to go to AGU and sometimes to GSA, but I don't think we're going to SEG. Okay, so thank you everybody, and hopefully see you at AGU. Bye-bye.